Hello guys, welcome back. Today we're going to talk about descriptive and inferential statistics. Before that we need to understand why do we need data analysis. Data analysis is needed when you have large volumes of data, usually termed as big data. Because of the information technology improvements and advancements in technologies, we are getting large amounts of data every day, usually measured in petabytes. That's how large it is. So we need to understand how to manipulate this data in order to infer and in order to get what we want. Because of that, data analysis has become a crucial part of our life. Our governments use our data, information, and management staffs use our data, and also the modern technologies use our data to shape our future and present. So when we talk about data analysis, what we are actually aiming at is using the available data to infer and to make decisions. And these decisions can help us to forecast and at the same time understand the context of their use. Let me give you an example. I have a set of data collected from Cricinfo about the victories made by each country in different tournaments or series and their margin, the winner, the season, etc. etc. So you can see that I have organized the data in a tabular form inside my Excel worksheet. From this, if I look at Sri Lanka's victories from the past up to 2020, I can see that how we have developed as a team. You can see 1992, 1993, we have a single series victory, of course, 1996 as well, and 1997, we have 3 series victories. So, likewise, if we properly organize our data, we can look into each clusters and make intelligent decisions about our data system. To understand statistics, we need to understand the frequentist perspective first. Well, in the frequentist perspective, we have something called a population. Population is a large set of data, or it contains observations that is unfathomably large. For instance, you can talk about human population. And if you want to study about something, you need to study the whole population, which is definitely impossible. Because of that, we need to find an alternative to study about the population to make intelligent decisions. That is why we usually take a sample from that population. We draw a sample and we try to understand the population from the sample. There is a question when you do something like that. Is the sample representative enough? Is it really representing the population? It's a valid question because you can take a sample from anywhere. For instance, if you look at this population, you can find number of people, nurses, doctors, students. What if I take a sample from here? Well, nobody can argue, and also I can take sample from somewhere there as well. And all these samples are drawn from the population, but I don't know whether these samples are representative enough. This is one of the fundamental questions in statistics, to understand the population and sample. Hey, and this is Joy. He's now studying data analysis with me because I'm doing this alone. Say hi. Hi, Joy. If you take a look at this, you can see that there is a population and you draw samples from that. And each time you draw a sample from the population, there is something called a probability, because you never know what type of sample you're going to draw from this population. That is why you have a probability of choosing a given sample, the sample observations you make from the population. This sample can be a representative of the population, and also it cannot be, depending on the context and depending on the way you have chosen. When you have a very small probability of obtaining such a sample from that population, we say that it is kind of not representative. And from the samples, we can create different descriptions. We can make different assumptions, for instance, let's say we can take count as a descriptor of that sample, and the average of the sample, also the mid value. If you per se you are counting the number of girls in a sample or boys in that perspective, then count becomes a descriptor for the sample, and average as well. If you are talking about let's say height of a set, then average is a descriptor sample. From this descriptor, can we make an inference about the population? If you have a set of kids and you are taking their heights, can you infer about all the kids in the world? How to use the sample to infer the population is what makes statistics a useful tool. In this video, we will be mostly talking about the descriptions or the descriptors, and because if you talk about the inference, the way you are going to infer about the population, it requires some further understanding of statistics. I'm trying to make it simple as possible. We'll talk about it later. For the time being, let's focus about descriptors. In descriptive statistics, what we generally do is presenting or summarizing the data in your sample. This summarization can be a mathematical abstraction like the average, where you count all the data points and divide by the number of data points to get an average, some measure about the sample that describes the sample. This is the most simple form, the simplest form of describing the descriptive statistics. Let's say that you want to measure the height of all the girls and boys in your class or batch. Well, going one by one is really impossible, isn't it? You can take some friends and measure their heights and take the mean of that height. When you have the mean and when you look at the observations, you will see that depending on the height of each person, there is some sort of a deviation, a variability from the mean that you have already calculated. So your descriptive statistics has a variability. The mean has a variability. In order to understand this variability, we need further discussions. Well, that is for a different day. Then see you next time.